Okay, cool. Yeah, so welcome everybody. Today I just wanted to give you a short demonstration of the advisory generation tool. This is actually a presentation or demo I gave in September, I think, last year. But this is the updated version because some things changed in between, and the handling of the tool changed. Also, the structure of the YAML files that we have for the advisories changed a little bit. So maybe I will share my screen. So, can you see the slides or? Yeah, perfect. So at the beginning, I just wanted to give you a little bit of context. So adbcurate is the name of the tool. The idea to automate the advisory generation process is based on a procedure that was applied before, where we actually manually check data sources for security relevant information. And then we had to basically write the advisories by ourselves, like manually, and then create a merge request, which has to be reviewed, and then it was merged at a certain point. So it was a largely manual process. I also linked the epic, the related epic here in the title. And the process looked a little bit like this. So there was some sort of data source, a data feed, let's say the NVD data feed that had to be checked. Relevant entries had to be filtered out. With relevant, I mean, if there is a vulnerability report in a data feed, like, for example, NVD, it does not necessarily cannot be related to a package, because advisories are mostly relevant in the context of software composition analysis. And when you're looking at an NVD data feed, for example, over 90% of the vulnerability reports you find in that data feed are not related to packages. And so the first challenge was somebody had to go to the data feed, had to look through it, had to figure out, is this relevant to a package that we care about, and then assemble information maybe from different sources, because it may not be all contained in this vulnerability report, create a merge request for GymnasiumDB, which had to be reviewed, and then at a certain point it was merged. And back then we also had a client-server architecture, which meant that for every advisory that was merged to GymnasiumDB, the related advisories also had to be like pushed to Gymnasium server, because back then we had Gymnasium server that was kind of the server that hosted all the vulnerability information with respect to composition analysis, vulnerable packages that we care about. And this is these are the data fields that are contained in an advisory. So we have a data field for an identifier. This is a unique external identifier. This would be, for example, a CVE, or it can be also another external identifier. With external, I mean that it's not controlled by us. This is some identifier that's put on a vulnerability report by an external entity. Then there's a package slug that we use internally to identify an advisory that is usually composed of a package type and a package name. So with package type, we usually refer to the language. So for example, or the package registry. So for Python, we have PyPy or PP. I'm not sure what the right pronunciation is. For Go, we have Go, just Go. Then we have Maven, we have packages for PHP, packages, and so on. So these are like the package types. And then the name is the name of the package as it is hosted on a certain package registry. Then the title is a short description of a vulnerability. We have a publication date. This is the date on which an advisory has been published. on a certain data source, and the date, which is basically the modification date. And we need this distinction to track updates that are made to certain vulnerability reports. Then we have an affected range field, which contains machine readable range of affected versions. So this is usually evaluated by the analyzers. Therefore, we are using the version syntax with respect to a certain package registry. So, for example, when you're using adding an advisory that's related to Python, and the package is hosted on some package registry related to Python, we are using the version constraint syntax for this particular package registry. And they all use different version constraint syntaxes. So Maven has its own syntax, Python has its own syntax. And this is basically what this affected range field contains. Then affected versions is the same, but it's just human readable. So this is like a string in natural text that's comprehensible by humans, containing the same information. Fixed versions is a list of versions that have been fixed, and not impacted is the same for a list of versions that are not, or basically just a different a different kind of range that's just saying that this version range is not impacted by a given vulnerability. So it's also a version range. The solution contains a solution string saying that please upgrade to a certain version. It's usually what we're adding there. Credit is just to give some honorable mentions to people that were involved in fixing a certain vulnerability or that were reporting it. URLs is a list of URLs that are related or providing additional information about a certain vulnerability. Then we have also CVSS vectors that are used to express the severity or to compute the severity of a vulnerability. And an internal identifier, this is the UUID. So this is just a string that identifies the vulnerability uniquely internally. Yeah, and
just before you move on, yeah, I had 2 questions for you. It's actually more a question and a comment. Do we have, just out of curiosity, do we have a job that is checking that the identifier is unique in the DB?
There is a check for that, yeah. So we have an automated check for the uniqueness of these identifiers.
Awesome.
Yeah.
And the second one, just to comment on the pub. Yes, please go on.
Oh, this is also true for the package slug. So we're also checking for uniqueness there. I mean, if you're about to add a new advisory that's already present, then also the DCI check would crash. Yeah.
Perfect. And the second one, just a quick comment on the publication date. We should make it clear that that's the publication of the advisory itself and not the publication of the advisory in our DB. That could be confusing for the users. But since we have dates underneath, I get that we should rely on dates, but if it's explicit, that's always better. Just my 2 cents.
Yeah. Yeah, makes sense. This is something I should add explicitly to the README MD on GymnasiumDB. That's true.
Thanks,
great. Yeah, this was just the slide just gives you an overview of the different data fields that we have. Some of them are optional, some of them are not. And the adbcurate tool now is what it does is it goes through an NVD data feed. It tries to identify what are relevant entries, and then based on that generates an advisory providing information for these several data fields that you can see here. And there are certain challenges that were associated with that. So as I mentioned at the beginning, NVD is very generic. So you have to figure out which entries are relevant with respect to composition analysis and to which packages they can be related to. And because related package name and types are not provided, usually in descriptions, you won't find them in the CVEs that are contained in the NVD feed. And also you have incomplete information. As an example, the CVEs that are coming from NVD feeds, they don't contain a title, they only contain the description. And it's hard to automate the summary of a description into a title. I mean, there are tools that do that. I tried some of them, but they don't work very well. So therefore, I'm also relying on CWE as another data source to basically pull in proper titles from there that can be added to the advisories. And then another challenge is that these data feeds tend to be relatively large. So there's for the NVD 2019 feed is about 60 megabytes and with 14,000 CVEs. And yeah, so you have to, because we want to reprocess them, we want to be able to reprocess them once in a while. You have to figure out a way to do it efficiently. And yeah, then the main challenge, I would say, or the biggest one in this list is to figure out how to relate the vulnerability descriptions or CVEs to packages. That was basically the main thing. All the other things that are in this list, they, for example, the title, we could pull it from CWE. And for solving this particular issue, we are relying on streams. So we consider the whole NVD JSON file as a stream, and then we just, while we're going through it, generate advisories. Oh yeah, this particular item I forgot to mention is that NVD or NVD entries usually they contain both. They contain version ranges, but they also contain explicit versions. So when you have an affected version range from 1.0 to 2.0, it might be that in the NVD feed they explicitly list every single version that has been impacted, and this is not what we are doing. And in our schema, we assume that you have a version range, and so we have to translate these explicit version into ranges. We have to translate this, which is not a big challenge. It's doable, but it was a bit nasty to do. So yeah, then I come to the biggest challenge. How could we identify NVD entries that are relevant to certain packages, and how to figure out these mappings? So for that, we are using information that's provided in every single CVE that's contained in NVD data feed, which is called a CPE. It's a common platform enumerator, and it contains information about the vendor, the product, and the version. And this vendor product information is very useful to us because in most of the cases, there's a one-to-one mapping between vendor, product, and package, a certain concrete package. It's not always the case. There are situations where you have one-to-n mappings. So it could be that you have a CPE that's covering 10 or 20 packages. That also happens. But in most of the cases, you can link a CPE directly to a certain package. And we are using this information. So while we're going through this NVD feed, we are looking at CVEs. We also see that these CVEs are linked to certain CPEs, and then we maintain a separate database where we store the relation between these CPEs and certain packages. Yeah, so this is just let's say a separate database that we're using for package resolution, more or less. The next question is that where did we get this information from? Because when we started, we didn't have a CPE map yet, so we didn't know about the mappings between CPEs to certain packages. And for that, we used some bootstrapping, and we basically did the bootstrapping based on information that we already had in our advisory database. So in GymnasiumDB, we already had a couple of YAML files. I think back then it was about 1,000 advisories that we had in the database, and 1,000 CVEs, I should say. And for bootstrapping the first CPE map, what we did is we basically went through the CVE files that we have in our advisory database. We checked the correlated NVD entry, extracted the CPEs from that, and then basically stored this correlation in a separate database. And then we had the CPE map database that contains the mapping between CPEs and packages. Yeah, we also used other sources for extending our CPE map. We used Friends of PHP, RubySec, then a CPE data feed that's provided by NVD. And based on this, we already had a good starting point for generating the first set of advisories. Okay, yeah, maybe I will just start with a short demo about how to apply, or how to run the bootstrap process. This is something that usually you don't have to do it. This is basically something that I'm doing once a month, something just to add new entries to the CPE map. But I'm also adding this information as a JSON file to the Git repository so that it can be easily imported. But I will just clone a fresh.
Is that the CPE map.json?
That's the CPE map JSON. Yeah. This is the JSON file that I can also show it to you here. So this is basically the prefix that contains the vendor and the product. And we say here that we would like to include the CPE mapping, that it is used as a valid mapping. And this is the list of CPE packages to which this may be related to. Yeah. So this would be this RBO package in PyPy. So there are some includes, there are also some excludes. So let me show this one. So for example, here we didn't come across a package yet that's related to Python Hyper, or there are also other ones that are, for example, OpenStack Octavia, where we didn't find a relation. They're excluded. We still add them because once in a while I'm going through them to check whether I can maybe add additional information to this CPE map so that these packages could be resolved in the future. And this is also the reason why reprocessing is so important, because whenever we change something on the CPE map, we want to be able to reprocess also older data feeds in order to pick up maybe new CPEs that we didn't knew of before. Okay, so the whole, once you've cloned the repository, there's basically a single makefile that manages the whole advisory generation and all the different steps that I'm mentioning during this demo, with a short like a short description about what these make targets are supposed to do. And one of these targets is make bootstrap CPE. And this is basically doing what I've just mentioned in the slides before. It will just go through the advisories that are already present in the database. We'll check the corresponding NVD or CVEs, and then look for mappings that it doesn't already know, and then extend the CPE map. But this takes a little while, because it goes basically for every single advisory. It goes to the corresponding website on NVD to fetch this information. So I don't want to run this through. I just wanted to show you how you can execute it if you want to try it out. But as I mentioned, this information the current information is basically already contained in a JSON file. So therefore I stopped it at this point. Okay, so the next thing I would like to illustrate is the advisory generation process. This is basically the interesting part. So here we assume that we have a CPE map, that there's a CPE map present that we could use, and then there's an NVD data feed that we would like to process. And this advisory generation contains basically of two steps. The first one is called filter and split. And what happens here is that we go through the NVD data feed and we check every single CVE. And for every CVE that has a hit in the CPE map, so that we know has a package relation, we extract the CVE. So we basically generate a new JSON file that only contains the information related to the CVE that we just hit and that we know is related to a certain package. This happens basically here, I mean, what I could have also generated a single JSON file, but it's nicer if you split them into single JSON files for debugging. So you could basically navigate to the single files and also look through the single files and see what was the CPE that caused this particular CVE to be identified as a CVE related to a package that we know about. And this is the first step, filter and split. So this is just to identify relevant packages and extract them. So here we extract them basically all relevant CVEs or CVEs that are related to packages. And then the next step is the advisory generation, where we take these files and translate them or transform them into an advisory according to our YAML schema that we are using with the data fields that I've mentioned at the beginning. And we are also taking some information from CWE here. This is basically the title that we are taking from an external source. So filter and split is basically cherry picking, and advisory generation is generating advisories according to our advisory format. And this is now I want to go through the single steps and show you how you can run them and how it looks like when you do this with adbcurate. And this is like the whole the overview of the whole approach. The interesting part, or the parts that I'm going to show you, are mostly focused on filter and split and advisory generation, because I think these are the most important ones. This here is the first part here is about the bootstrapping that I showed you at the beginning, how you can bootstrap a CPE, but this is something that you don't do on a regular basis usually, because in most of the cases we are mostly interested in CPEs that are related to the NVD feed that we're looking at the moment. And this here is more like taking all the CPE mappings that you're getting. But it was good to have a starting point, basically. Okay,
would we want to grab, say with the NPM, get the list of all of the NPM package names and then add that directly to the CPE map?
That would be possible if you can get the related CPE information. So if you could basically collect all the packages from NPM, for example, but you still don't know to which CPE they actually correlate, because there's no unique fixed schema that they're using for defining the CPEs. So that's, I mean, that would be the perfect approach, because then you would be complete with respect to the package names or packages that you're considering. The only problem is how to figure out the CPE for a certain package.
Okay, yeah, that makes sense.
So yeah, then let's just generate a couple of advisories for maybe the NVD data feed from 2020. So the first thing to do is I've in the make file, I've defined a variable which is called data feeds NVD that contains the data feed that you would like to check for advisories. And if in this case, I'm using the data feed from 2020. So the first thing I'm doing is I'm basically calling the target collect feed NVD. And what it does, it downloads the most recent data feed from NVD and stores it in NVD feed in the directory NVD feed in. And I can have a look at this. So this is basically the most recent version of the NVD data feed in JSON format. And after I've downloaded this file, the next step is this filter and split step, which I'm invoking. So I'm calling make filter and split NVD. And what this target does, it's going through the JSON file and looks for CVEs that are relevant to certain packages. And this information is then stored in NVD feed split. So you can see that we have a couple of JSON files now here that contain the same information as the data from the NVD feed. The only difference is that we basically also already added information regarding the package to which this CVE relates to. Because we already have this information, we added this to the JSON file. So, for example, the CVE that you can see here, this is 2020 1925. This one corresponds to the package OData server core, which is a Maven package, basically. So we already added this information here in this slugs array. And you can see this is also information that's already contained in the NVD feed. In this case, they were using the range syntax, which is much nicer than the other syntax that they also have, where they basically explicitly, or they give start and end of a version range as affected range, which is quite helpful in this case. So these are now the CVEs that we cherry picked from the data feed. And the next step would be to
multiple ranges.
Yeah, it's also working if you have multiple ranges. Yeah, it's implemented in a way that if we have multiple ranges that are reported, we kind of put them into a set of ranges essentially. So we have a list of ranges that we are using, and this also works for when the versions are mentioned explicitly, we squeeze them into a version range. And so it can be also used if you have both cases, if you have a situation where you have multiple ranges and some of them are reported using the range syntax, others are reported using the explicit version syntax, then they are kind of put together into a list of ranges. Yeah. I mean, it's... oh, sorry.
Oh, keep going. If it's on the same topic, question that Philippe had, I've got a different question.
Yeah, I just wanted to add that there are sometimes there can be cases where we will have some false positives where this squeezing doesn't properly work, or that there are some versions that were missing. This happened, but in most of the cases it is working. That's the reason why we still have this manual reviewing step in between to spot these problems. But in most of the cases, this version detection mechanism works pretty good.
Nice.
James, you had another question, or?
Yeah, the format of those CVE JSON files, is that a format we came up with, or is that a standard that we are using? Like an existing standard somewhere?
basic for the JSON format. You mean the JSON or the YAML format? Because
JSON.
because the JSON format here for these JSON files that are generated after this filter and split step is essentially exactly the same as they appear in the NVD data field. It's basically just extracting them and using the same data fields. This is just an intermediate step to do some cherry picking, and to kind of organize them in different files, which makes it a bit easier because when you're going through them I'm processing the NVD feed in a stream, and when I'm coming across an interesting CVE, I'm just pushing it out as a file while I'm going through that. But the data format is the same as the one for the CVEs that are contained in the NVD feed.
Yeah, that makes sense.
Okay, so the next step after doing the filter and split would be the advisory generation. So for that, we also have an extra target called make generate advisories NVD. And when I'm invoking this call target, it will basically go over these JSON files and will translate them into our own format. And it will put them into the advisories out directory. So here you can see that we have now the advisories are kind of organized in the way that's specified in our schema. So we have like the package types Maven and PyPy on the top level, and then the package names. Here for Maven, it's a bit more complicated because you have group ID and artifact ID, but for PyPy we just have pillow as a package name, and then the CVE, which is the identifier. This is basically the organization is based on our schema, and when I'm looking into one of these advisories, then you can see that we have the identifier, which is the CVE package slug, is basically the same as the directory structure to that advisory. The title is based on the CWE, and in the description, this is for now the same description as the one that you also see in the NVD and CVE. And then the date, pub date, affected range. This is now the affected range based on the Maven version constraint syntax, where 4.00 is the lower bound and 4.7.0 is the upper bound. And the fixed version information that has been pulled from Maven Central. So we basically check for the first version that doesn't fall into the affected range, and then put this into the fixed version list. And affected versions like these fields here, affected versions, not impacted, and solutions, they are essentially generated from affected range, because there's kind of you can think of them as redundant fields essentially, because you can generate them from information that you already have in your own advisory. So affected versions is basically a string that's generated from affected range, because we know lower and upper bounds, we can basically just generate this. And not impacted is essentially the inverse of affected range, so we can also compute this automatically. And
what if the affected range is multiple ranges? You know, it's like 2 different major versions or something.
So if you have multiple ranges, what we're doing is we are essentially inverting them, and then we check for the first version that falls into the so as we inverting them, we are generating a new list of ranges, basically based on that. And whenever there's a version that falls into this new list, we consider it as fixed. And this is basically the approach we are using there. Yeah.
Nice.
Yeah, and then the UUID is generated automatically, and these CVSS vectors, they are also provided by the CVEs. So this information is already contained in the NVD feed. Okay, so usually what I'm doing now at this point is I'm removing version information, for example, from the description because it's redundant and as it's already contained here. And I'm also, if there are situations where you have classes, for example, I'm using Markdown syntax. So there's some editing that I'm doing usually on these generated advisories. That's just to remove information that's not really needed at this point and to make it consistent with what we already have in our database. But just for the sake of time, I will just go on with the next step, which would be to generate merge requests from that. So now we have the advisories, but we still need to generate merge requests according to our contribution guidelines. And at the moment, our contribution guidelines, they say that you have that your title has to adhere to a certain format, that you have to add certain labels to your merge request. For example, package type has to be added as a label. And we also have one merge request per advisory policy. So saying that every single advisory we're adding is basically added through a single merge request. Therefore, there's another make target that we can use first. And this make target is called prepare MRs. And what it does, it's basically just, we have a local copy of GymnasiumDB, and it's basically just adding branches. And per branch, we're adding one single advisory. And this happens with this make target. And let's just go into our local copy, and you can see that we have like now, maybe I should grab for curate. We have now a couple of branches that have been created for these advisories that we want to push. And there's also another target whenever you have pushed, because when you're processing an NVD data feed, it can be that you have like 20, 30, 40 branches, and at a certain point you want to get rid of them. So there's a make purge branches, which just deletes all the branches that are related to adbcurate, so that you can like start from scratch. Okay. And then the next step would be to push them, to generate merge requests on GitLab. So there's another target called push MRs, and what it does, it's for every branch that you have locally in your local copy, it will generate MRs on GymnasiumDB. And can just go to. So this is now an MR that has been created for Pillow. And this was the one I edited. So this was the Apache Olingo one, yeah. And what I'm doing is this is basically the old checklist. I'm still adding it to the MR description, but it's not really required anymore because all of these fields are generated automatically, so we don't have to check them anymore. I'm also adding a couple of useful links at the top that makes reviewing a bit easier. Whenever you're not 100% sure about an advisory, about the content of an advisory, if there's some contradiction, then you can always go to the Maven repository page or to the original CVE page to check for consistency or for other issues. Yeah, usually what I'm doing here then is I'm doing a last pass. I'm checking whether there are some some issues. I'm also looking at the CI jobs that are running on the advisories. So, for example, for this particular one, everything is okay. So there are some sanity checks that are executed on these advisories, and then if everything is okay, I'm resolving the VIP status and I'm assigning it to another reviewer. Let's just, maybe I can, Titiana, for example, in this case. And then there's a final pass. And if this is okay, we just merge these advisories to the database. Okay, this is basically the workflow. So starting from the MVD data feed through the filter and split step, advisory generation, then MR generation, and then hopefully it ends up in the Gymnasium database, and and then once in a while I'm also applying the bootstrapping step again, just to get to know new CPE maps. Yeah, this was basically just a short walkthrough. If you have like questions or suggestions, maybe.
Yeah, definitely have a couple of questions. All right, so the workflow, how much of that right now is automated? Is it like a recurring CI job in GitLab on the advisory DB curation tools project, or?
No, at the moment I'm hitting this manually. So I'm starting the jobs manually, and this has, I mean, it has some advantages when it comes to reviewing, because what I'm usually doing is I'm processing an NVD data feed, for example, from 2018. I'm generating advisories for that, and then I'm editing them locally. And so I will usually have a batch of a couple of hundred of advisories, maybe 100, 200. And then once I've reviewed this like batch, I'm generating MRs for them. And this makes the reviewing task easier for whoever does the final check on Gymnasium DB. But putting this into a CI job, this would be definitely nice to have, especially when it comes to checks for updates of NVD feeds. So you could have some sort of scheduled CI job running, checking whether something changes on the NVD data feeds that are published on the NVD page, and then fetch them and extract the related advisories and then create some MRs. But before we could do that, we would have to figure out a way how we could efficiently mitigate false positives. Having some sort of blacklisting would be great for a start. I have some very primitive approach, but it's not good enough, because we would have to have some sort of loop that whenever you notice false positive, maybe while reviewing on GitLab, for example, you would have to mark this somehow as a false positive, so that we could kind of get this information for the next iteration when we're going through an NVD feed. But
are the false positives usually us thinking that a CVE is about a package when it really wasn't, or is it some other type of false positive?
Yeah, it's exactly that. So there's a situation at the beginning. I've mentioned that CPE maps are usually, there's a one-to-one mapping between CPEs and packages and types, but not always. So especially for Go, it's really terrible, because they have one single CPE, but the CPE is related to 10, 20 Go packages. And then you generate 20 advisories, but only one of them is actually related to the package you care about. This poses some challenges, especially for Go. Also for Maven, you have that a lot for Maven too, because they also like to split, they compose their packages into sub-packages. So you have like one parent Maven project, and then you have a lot of different smaller packages, but it's still one single CPE, and this is problematic for some package types more than for others. For NPM, for example, it's not that big of a problem. For gems, it's usually you also have one-to-one mapping, and Python too, but especially Maven and Go, they are, and sometimes, for PHP, you sometimes also run into this situation. For CMS, I think it was Symfony. You also have a one CPE, but a lot of packages that are related or covered by the CPE.
Okay. Yeah. All right. Yeah, that makes sense. So I was thinking more too about what I mentioned before about doing like spell checking, and to help it be as automated as possible. I think there's some like grammar checking command line tools we could use as well, where you check the spelling and filter out anything that's related to a product name, basically anything in the CPE, because it's going to say all those are misspellings, and then do a grammar check on it. Are the descriptions, do we use, the title comes from the CWE, right?
Mm-hmm.
And the description, we just take whatever is in the NVD database, right?
Yeah. We take it, but I check every single one of them usually because of these markdown issues and version issues, because I have to delete the versions from them. This is also good for cross-validation, because I can check whether the versions mentioned in the description actually match the versions that are explicitly listed in the CVE. So it's also has an additional advantage, additional value, because sometimes you can notice that there's like an inconsistency between the version mentioned in the description and the one that's mentioned in the affected versions field of the MVD field.
Gotcha. That makes sense. Okay. And so what you did in the demo, was that all of the vulnerabilities that we currently think are related to packages just since this year? Or was that like just today or something?
Yeah. This was since 2020, all the since January 2000, the 1st of January 2020.
Oh, okay. All right, so that wasn't too many. And then we're still catching up on previous years.
Most of the work that we why the further automation is useful is, I think, mostly because of backlog processing for older NVD feeds, 2018, 2017, 2016. Because when it comes to new advisory on new advisories, I would say that per week, usually you have maybe 10, 15, not more than that.
Oh, nice. Yeah, it's not too bad. Okay, I have a lot of other questions about the types of manual editing that we need to do. So if we're working on the backlog, it's like adding backticks around, like, a function name or something. How often that needs to happen, and like, maybe things we could do to automate it as part of the merge request, so that there's as little as possible that we need to do manually.
Yeah. So I would say in 100% of the cases, versions have to be deleted from the description, 99%. Regarding the backticks, this is, I would say that maybe in 50% of the cases, there are class names or other keywords where we could put these around. But the nice thing is you could actually detect this, I think, automatically for some languages. For Java, in many cases you can. If there's like a camel case word. Oh, sorry.
Not a problem.
I think I got dropped out.
So the last thing I heard you saying was that class names, so versions always have to be deleted, and class names, and I think you were about to say functions or something like that.
Yeah, so I think for functions and class names, you could actually use some sort of regular expressions to detect them. That would be doable, I think. What's a bit nasty sometimes is that vulnerability reports, they sometimes get generated automatically. So I think that they are generated from tools, and then they are basically incomprehensible. So they use some internal structure where they say that affected component colon and vulnerability type colon, and then they put something there that I mean these cases I think have to be edited manually, but it's maybe it's just like maybe 10% is not that much. I mean the biggest
Okay.
Biggest things are versions, because they always mention them explicitly also in the description, and class names and functions. Yeah,
Okay.
that can be done.
Are the descriptions from NVD ever too big and we have to summarize it ourselves?
In most of the cases, they are okay. There are even cases where they are too short, where they just put one single sentence in. Then it's even shorter than the title that we are using. But if they are too long, it's mostly because they are related to other CVEs, and then they also reference other CVEs in there. But these are, so this is in these cases I just delete the sentences if they don't really explain or add some useful information with regards to the nature of the vulnerability. I delete them. Yeah.
Okay. All right. If that was a common problem, I was going to say we could use, so on Reddit, there's the auto TLDR bot that summarizes articles for you. It does a great job. If that was a problem we had, I would consider maybe using that to automatically generate a summary, but it doesn't sound like that's too big of a problem.
Not really, no. It doesn't happen, I would say, too often. So this would be something that we could, I think, still fix doing reviewing. Yeah.
Okay. All right.
And I see that there are some comments also now. Okay, yeah, this was a question.
They were addressed already. Don't worry.
Yeah.
Thanks. That was extremely useful. Thank you for putting this together.
Yeah, definitely.
Yeah, I just wanted to to go a bit through the workflow. I didn't go into implementation details or something because I thought that I just wanted to show how I'm using it at the moment. It's also nice to get some feedback about how we could improve this process itself, this workflow that we have at the moment, to increase the throughput and number of advisories.
Yeah. I like it.
Yeah, there's also the I think I already sent you the link to the tools. Just put it in chat. Yeah, this is the I added a more detailed description there.
Yeah, I was following you along as you went through the makefile. Yeah, so thanks for that. I like that a lot. Nice.